Hello everyone. The main topic today is the COVID-19 testing accuracy using Bayes Theorem and conditional probability. Let's dive in with me into more details about what is actually false positive and negative is. Let's imagine that you threw back the breakthrough, widespread testing, lockdowns, vaccines, then pivot, and the interpretations matter. With the advent of the vaccines and the imminent ending of the lockdowns, we might think that the secure of COVID-19 is coming to an end. But this would be wrong. Or have you ever wondered if the result of the test get COVID is a liar? In case I catch an like disease symptom but test negative, should I trust it? Or no symptom at all, but positive testing. Really am I infected? So that is the reason why today I will use Bayes' theorem to quantify the uncertainties and see why accuracy claims can mislead. And the main goal of this lesson is to answer how likely you would have got the error in the test by chance. To propose a method for teaching probability using Bayes' reasoning to build the outcomes of true positive depends on the prior probability. When we have the coronavirus test, is that there are two possibilities that come up to you, either positive result or the negative result, right? And for example, when someone who is exhibiting COVID-19 symptom but receiving a negative test result, this can contribute to a disease spreading, right? A mistakenly believing they are virus-free. That is such important risk, right? So the desired outcome is not the negative result, but is actually a negative test result and the confidence that the result we get is correct. And to further understand about the topic, I will decode the test result so that we can tell the difference between just simply getting a negative result and being confident is a truly negative. First thing is, yeah, is the most important terminologies. The first thing is truly positive. It's just simply say that we have COVID, but the test say yes, you have COVID. Is a true positive. But the opposite of the true positive is the false negative, which means when you actually have COVID, but the test say no. Another case is the true negative, which means you don't actually have COVID, and fortunately, the test say no, you don't have anything at all. But the opposite is the false positive, which is why you don't have COVID, but the test say yes. It's really surprising you. And the most important outcome that we want to cover today is the positive predicted value, or PPV, and the negative predicted value, NPV, which means that after a positive or after a negative, how likely are you actually infected, or how likely you truly not infected at all. When we comes up to the test accuracy, we have some terminology for that. For example, the prevalence, which is the total number of infected patients, which is get exposed to the COVID. And the second terminology is sensitivity, is the sensitive enough to detect whether someone actually has a COVID. And the final one is the specificity, which is opposite to the sensitivity. Do we actually know the specific disease? So this may be misunderstanding or a bit confusing for you. So let's dive into one of the example. The first of all is to the state. To illustrate the potential magnitude of this problem in general populations, let's consider the following example from Spain and the United States. Assuming a test with 90% sensitivity, the president of the region of Madrid has predicted that up to 80% of Madrid, set by 5 million residents, will become infected by COVID-19. Let's look at our solution for that. So step 1 is to define the sensitivity. If you have COVID, it states that there are 90% chance the test is positive, which is given the fact that you have COVID and the test says yes, is 190%. So we can conclude there are 10% false negative rate, which means when you actually have COVID, just 1 out of 10 people actually have COVID, but the test say no, you don't have. It's really dangerous, right? And step 2, the populations and infection estimate. We got the total populations of Madrid is 6.5 million, and the percentage for infection rate is 80%. So the probability of total numbers who have the COVID is equal 0.8 plus the total population is equal 5.2 million people infected or get exposed to the COVID-19 disease. And the final step is applying sensitivity, which is 10% of 5.2 million is 505,020. No, actually 520,000 people. So, even with a good test, about 500,000 infected people could test negative. You can believe that? No, absolutely not. That is the reason why it comes to Bayes Theorem. This is the formula for our main topic today. State that probability of A when B has already occurred is equal to the probability of B when A has already occurred multiplied by probability of event 8 and all divided by probability of B. When we put it out for our specific case, which is we have the marginal probability with any knowledge of all the event. Also, we state the probability of COVID and the probability of positive result is the marginal probability. Easy, right? And the probability of positive result, given the fact that people infected, which is called the conditional probability. Okay, secondly, we're introducing the general concept of the contingency table, or also called raw frequency data table, that can be used to explain the concepts such as false positive and false negative, some a bit confusing terminology that we mentioned before. In short, rows are what the test said. If you look at the rows, which say positive and negative, is what the test say, and the column are the true people who have COVID or people who don't have COVID. And the single word, or for example, TB, phobies, FN, TM, will stand for all the terminology as we mentioned. is the joint probability. For example, on the top left, the TB stands for true positive. This is the case when people has COVID and the test is positive. Yes. And the row or column totals on the corner of the bottom right is the marginal probability. At the top row is the TB plus FP, which is the probability of positive. FN plus TN, which is the probability of negative. And I know it's still a bit confused, so let's go through some COVID rapid test insight for case study. Suppose a number of 10,000 people are given rapid COVID test would provide faster but less accurate result than PCR tests. It just gives you the context of the whole case. And consider the rapid COVID test that correctly detects 70% of COVID cases and is accurate 98% of the time for adults who do not have COVID. Although the reliable prevalence data are difficult to define, suppose for the example, thus the prevalence of the COVID among our population is 4%. When we plug it out all the data into our raw data table, we look at the order I've noted here. The first one is the probability of COVID, which is called 4%. So the probability of people do not have COVID is the implement of the probability of COVID is equal 1 minus 4%, 100 minus 4%, which is 96%. And follow the orders, we got the following number like this. And when we when we convert to count for total numbers, total populations, 10,000 people, we got the TBs or the true positive is equal to 280, which means 280 people who is infected were correctly detected. That's not perfect, right? This allocates not what we want. And the the FB, the false positive, stay 192, which means 192 not infected people was told they positive. And when we applied Bayes, uh, we read straight off the table. We got the marginal probability, as we mentioned before, the probability for COVID is equal for boys 72%, and probability for negative result is 95.28%. And the trial probability also stay like that. What we want to focus is the positive predictive value, which is among all 472 positive. The PPP state that about 3 in 5 positive are real, which is just 59% of positive are true infections, and up to 41% are false positive at 4 prevalence. And the same case happened similarly for the negative predictive value. So that's all I want to cover in our lesson to define how likely we got the error and how likely we got the right decision for the COVID-19 test. And the final things that I want to mention is the minimizing the error in the COVID-19 testing. You can look through all the slides. Thank you for your enjoying, and yeah, hopefully any feedback are really valuable for me for this lesson. Thank you for listening.